So far, the problems that we've dealt with in determining the derivative from first principles were just expressions, right? So now we're going to tackle questions on which the original function itself it consists of a fraction, just like you can see here, right? So we're given f at x is equals to 2 over x, and they want the derivative from first principles. So what are we gonna do there, right? The procedure doesn't change. Remember that the derivative of f, right, would be equal to the limit of f of x plus h minus f of x, all divided by h, is our h approaches 0. So what are we gonna do? We're firstly gonna find f of x plus h. So remember, to get f of x plus h, I'm gonna substitute x plus h where I see x. So I'm gonna have 2 over, now we have x there, so I'm gonna say x plus h. Okay, so this would be f of x plus h. Quite simple, right? Now we have to substitute that in this equation because now we have this one is already given, right? So we substitute into the formula, then we're gonna have the limit of 2 all over x plus h as our f of x plus h, right? Minus f of x, which is 2 over x divided by h as h approaches 0. Okay, now that we have a situation like this, we need to be careful, right? We need to simplify as much as we possibly can here. For us to do that, we need to remember the following about fractions, right? That we learned in lower grades. Okay, let's remember that if I wanna, let's say I had 1 over 2 plus 3 over 5, and then I wanted the answer without using a calculator, how would I get the answer? Well, the answer, you get it by saying this number, the denominator, right? So we're gonna say this denominator times that, 2 times 5. Okay, then after that you're gonna say 5 times that 1 there. Okay, so you're gonna have 5 times 1, I write it on top, then you say plus 2 times 3 there. Okay, 2 times 3. So the answer would be 5 plus 6 all over this is 5 here. Okay, this is 10 therefore, so we would have 11 over 10. Okay, so we're gonna apply a similar procedure on this here. Okay, on that fraction on top. So we're gonna have the lim of, now we're gonna say this denominator times that denominator, so we're gonna have this and then have x into x plus h. Okay, so we're gonna have x into x plus h like this. All right, that's our denominator. Then we're gonna say x times that 2 there. Okay, what is x times 2 there? Yes, that will be 2x. You write it here. Then you say this times that. Okay, the sign in between is minus, so I'm gonna write minus. Then I say x plus h times 2. That will be the same as saying 2 into x plus h. Okay, so this is what we're gonna have. Now do not forget that all of that is divided by h as h approaches 0. Okay, then we're gonna have the limit 2x, we're gonna have 2x, and then negative 2 times x will be negative 2x, and then negative 2 times h will be negative 2h, all of that divided by x times x, that will be x squared, and then x times h, that will be hx. Okay, so all of these, remember, it's divided by h as h approaches 0. So for you to always remember your numerator, you can put it in brackets to say this is your numerator there, so I'm putting it in brackets. Okay, so now that we have a situation like that, what is going to happen? This is gonna cancel that. Okay, so now you would be left with the limit of negative 2h divided by x squared plus hx, right? Then now you see this division sign. I'm gonna write it as our normal division sign. I'm gonna say divide, then I'm gonna say by h. Okay, so instead of putting this as divided by h, I'm gonna write it as divide by h. So I just wrote this sign in that way there. Okay, remember it's just this sign, I wrote it that way there, then I put my h there. Why did I do that? Because I want it to be easy for me, because remember that if I have a divided by c over d, right, this is the same as saying c multiplied by a, right, this a multiplied by d over c, meaning the reciprocal of this thing there. Okay, the reciprocal of that. So we're gonna do the same thing here. Remember, this h is over 1. Any number is over 1, right? So for me to remove this division sign, I'm gonna put multiply, then I swap the numerator into denominator. So I'm gonna have the lim of negative 2h all over x squared plus hx. Then I'm gonna say multiply by 1 all over h. So I just I swap the numerator denominator. The numerator is now the denominator, and then the denominator is now the numerator. That's what we did, and now we have multiplied as h approaches 0. So now what is going to happen there? Now you can realize that this h as a numerator and as a denominator, and h as a numerator, so they're going to cancel out. Then what are we going to be left with? We'll be left with the lim of negative 2. Negative 2 times 1 is just negative 2, right? And then this times 1. Remember, when you cancel something, 1 is left. Okay, 1 is left. So all of these times 1 is the very same thing, x squared plus hx. And then as h approaches 0. Alright, so now that we have a situation like this, we are now ready to substitute h as 0. Okay, now we can substitute h as 0. So now you're not gonna write this when you substitute. So you're gonna say negative 2 over x squared plus 0x. All right, then your answer would be negative 2 over x squared. Then this will be the derivative of f. Okay, as you can see, it's just a bit of work, but it's very, very simple. What I need you to realize that, why are we substituting h as 0 here? Why didn't we do it earlier on? If I did it here and substituted h as 0 here, remember h would have been a denominator, so I would have been dividing by 0. I would get undefined, so we don't substitute by h as 0 here. Why didn't I do it here? Still the same thing, I'm dividing by 0, so I would get all of these to be undefined, so I don't substitute h as 0. What about here? Now remember, when I got multiply by 1 over h, I still couldn't substitute h as 0, because if I were to put h as 0 there, I would have 1 over 0, which is still undefined. Okay, which is still undefined, so I couldn't substitute that. That's why I had to cancel h first, and then after that, now I can substitute h as 0, because I won't get undefined as my final answer. And as you can see, the final answer is defined. Okay, so that is how we solve it there. So the second one that we have is this one. As always, you can give it a try. Okay, you can pause the video and try it out, and then after that you can check the solution. Alright, so how would we do this one? It's similar to the one we just did. Our f is also having a fraction, so how do we find the derivative in that case, right? So first of all, I'm just gonna try and simplify our f first, right? So our f at x is negative 1 over 3 x cubed, which can also be written as negative x cubed all over 3. Okay, because remember, any number is over 1, so that thing is negative 1 over 3 times x cubed over 1. So this times that is this negative x cubed, this times that is 3. Okay, so that's why this can be written like this as our f at x. Then the next step is to find our f of x plus h, right? So our f of x plus h would be, where we see x in this formula, we're gonna put x plus h. So I'm gonna say negative into x plus h all cubed divided by 3. Okay, that. Now you can actually simplify it from here, right? Simplify that top part. So you can say you have negative into x plus h times x plus h all squared. I think now you know that it's gonna be like this, and then we're gonna simplify. So we're gonna have negative into x plus h, and then we're gonna have we'll take the first term, we square it, we're gonna have x squared. The second term is squared, you're gonna have h squared. Then you say h times x, it's hx, and then multiply the answer by 2, you're gonna have 2hx. Alright, then you have all divided by 3. Right, then we're just going to simplify further there. Now you're gonna say, remember, you're gonna say this times that, then this times that, right, then this times that, and then you do the same thing for h, right? So we're gonna have the negative is outside, so we're gonna put our brackets. So we're gonna say x times x squared is what? Is x cubed, and then x times h squared, you're gonna have what? H squared x. Remember, we always want to write x as the last variable. X times 2hx would be 2hx squared, isn't it? It will be 2hx squared, because x times x is x squared, right? Oops, I've run out of space, so let me just quickly take out these here, then we can continue, right? So now that we have that, we now go to h. So I'm gonna say, what is h times x squared? That would be hx squared. Then what is h times h squared? That would be h cubed. And then what is h times 2h squared? That would be 2h squared x, right? And then we have that all divided by what? By 3. So it's always best to simplify your f of x plus h first, right? So now that we have this, we're going to check out our like terms, right? If you can check, you have h squared x, you have h squared x. Oh, sorry. We have h squared x, and we have h squared x, right? Then what also do we have? We have hx squared, and then we have hx squared. Those are our like terms. So we're gonna collect them. We're gonna say we have negative into x cubed, right? And in these are like terms, we're gonna say 2 plus 1 is what? It's 3h squared x. And then these are like terms, what is 1 plus 2? It's 3hx squared, and then you have plus h cubed, right? All divided by what? By 3, right? So the last thing we're going to do is now multiply the negative inside. Okay, so you're now gonna have negative x cubed minus, remember, negative times positive is negative, then you have 3h squared x. Negative times positive is negative, then you have 3hx squared. Negative times positive is negative, then you have h cubed. All of that divided by 3. So this would be your f of x plus h. Wow, quite a lot, isn't it? Let's go back and remember, we started here and then we simplified it to there. Our f at x is equal to negative x cubed over 3. So let's write it, right? Our f at x is equal to negative x cubed over 3. So we're gonna take this f of x plus h and our f at x, then you substitute into our formula for limit, for the derivative, right? To get the derivative from first principles. So we're gonna say the derivative of f would be the lim of f of x plus h, right, minus f of x, right, all divided by h as h approaches 0. So we're gonna say the lim of, so what is our f of x plus h? It is the one that is on top there. So we have negative x cubed minus 3h squared x minus 3h x squared minus h cubed. Then we have all divided by 3. That is our f of x. And then we have minus into, we have negative x cubed over 3 as our f at x. So remember this part here, right? That is our f at x. And then this whole part here, this one here, right? That is our f of x plus h. Okay? So that is what we're going to have then, right? Now, what can we do? We have all of that divided by h, right? As our h approaches 0 there. Interesting. So now what do we do next, right? We continue. Okay, we'll continue from there. So now we're going to have the limit as h approaches 0 of this one. You can rewrite it as it is. You have negative x cubed minus 3h squared x minus 3h x squared minus h cubed, all divided by 3. The negative times negative is positive, so you have positive x cubed over 3, and then all divided by h. Alright, so now what is the next step when you have something like this? Remember that let's have our little flower to remind ourselves. 1 over 2 plus 2 over 2 is equal to 1 plus 2 over 2. Remember, if the denominator is the same, you write the denominator, then you just add the numerators, as you can see there, right? So we're gonna do the same thing here since the denominator is the same. So we're gonna say lim of a negative x cubed minus 3h squared x minus 3h x squared minus h cubed plus x cubed. We have all of that divided by 3 because the denominator is the same. So I just took this is the plus x cubed. You see now it's on top. Then all of this, remember, is divided by h. Now at that point, I'm no longer going to write the long division sign. I'm not going to write that sign. You remember the division sign is divide and then divided by h, right? As h approaches 0. Okay, so now what do we then do when we are here, right? As you can see, this one is going to cancel that one. They are the same thing, just have different signs. And then that's what we have, right? So now here what we are left with, if you can check, you have h, right? You also have h here, right? Then you also have h. So we're going to take that h as a common factor. So I'm going to say lim as h approaches 0. I'm going to say h into negative 3hx, right? And then minus 3x squared, right? And then because I took the h, right? If I take one h here, I'm left with h squared. All right. So we have that divided by what? By 3, right? Now remember, this h is h over 1. To remove this division, we're gonna say multiply. Then we multiply by the reciprocal, meaning I swap the denominator and the numerator. Now that I have something like this, what is going to happen? H is gonna cancel that h, right? Then lastly, what are we left with? The lim as h approaches 0 of negative 3hx minus 3x squared minus h squared. All of that would be divided by 3. Okay, all of that will be divided by 3. But now, because h is no longer a denominator, we can substitute h as 0. So we're gonna say now we have negative 3 into 0x, then minus 3x squared minus 0 all squared, then we have all divided by 3. Okay, so now this part would be 0, then we are left with negative 3x squared, then this part is also 0, right? This one is gonna give us 0, so we are left with this all over 3, right? So it means the final answer would be negative x squared, right, as our derivative there. Okay, so that is the derivative. Quite interesting, isn't it? So just remember, this is 0 here, this is 0 there, so we're left with this over 3, and then we get that this over derivative. So the derivative of f of x is equals to negative x cubed over 3, right? The derivative is equal to negative x squared, right? This is the derivative there, right? So that is it. The next thing that we're gonna do is to look at differentiation rules. Yes, we're gonna look at differentiation rules. So far I hope that you have seen all type of questions that they can ask you on derivative from first principles. Okay, lest I forget, there is also one other type of question on derivative from first principles that they can ask you, right? So what if you are given f of x is equal to the root of x? How would you find the derivative from first principles here? Well, for this one, right, you just have to do a similar thing. Okay, so you have to find your f of x plus h, which would be the square root of x plus h, right? Then after you have this, right, you can then say, all right, the derivative of f would be equal to the limit of f of x plus h, right, minus f of x, and then we divide by h as h approaches 0. So remember, what did I just do here? Where I saw x, I just substituted with x plus h. Where I saw x, I just substituted with x plus h to get f of x plus h. You saw that, right? So I'm just gonna substitute my f of x plus h, right? So my f of x plus h will be square root of x plus h, then minus my f of x, which is the root of x, all divided by h as our h approaches 0, right? So now that we have a situation like this, remember, if I substitute h as 0, I get undefined, so I have to simplify first. So what am I gonna do there, right? Seems like a dead end, but it's not. Okay, this is what you're gonna do. You're gonna multiply here by what we call, this you can put it in brackets, right? We're gonna multiply by what we call the conjugate. Okay, the conjugate of the numerator. What is a conjugate? A conjugate is the very same thing here, right? It's the very same thing here, right? So we're gonna say x plus x, but instead of having a minus, we're now gonna have a plus. Okay, so it's the very same thing, just a different sign in between. We call this one here a conjugate, right? I know you might be knowing conjugate from acids and bases, okay, but this is something which is similar to that, but in maths. Okay, so this is a conjugate. You're gonna multiply by the conjugate on the top and also on the bottom. Okay, so on the bottom too, we're gonna multiply by the very same thing, so we call it the conjugate. So this whole thing will be equal to 1, so it's like we didn't do anything, but we know that we are heading somewhere. Okay, so now what are we gonna do? We're now gonna say the lim of the conjugate, this times the conjugate, so we're gonna have root x plus h minus root x, right? Then you multiply by root x plus h plus root x, okay, all divided by h into root x plus h, right, plus root x. Okay, so as h approaches 0, now this method usually it's applied at university level, right? But you never know, examiners, they might just pop it in there, right? So you gotta be prepared all the time. So whenever you have a radical sign, like a radical sign, you just have to know that you're always gonna multiply by the conjugate, okay, to get the derivative from first principles. So now that you have something like this, you're gonna say the top times the top, then this times that, right? So now you're gonna use your FOIL method, right? So you're gonna say this times that, then say this times that, right? Then this times this, and then this times that. Okay, so when you do that, what are you gonna have, right? You're gonna have this times that. Remember, square root of something times square root of something, square root of a times square root of b, right? Remember, as long as it's a square root and a square root, you cancel, then you are left with just a times b. No, that's not what I wanted to show you. In fact, that's not what I wanted to show you. I actually wanted to show you this, that square root of x all squared, the answer is just x. So square root of something all squared is just x. So this is the same thing we have here. We have square root of x plus h times square root of x plus h. So it's more of like we have something like this. Okay, then this times that there, that will be square root of x times square root of x plus h. So it's this times that, right? Then we have this negative root of x times square root of x. So we're going to have negative root x times square root of x plus h, right? And then we're going to have, right, let's just create some bit of more space. Sorry, let's just create some bit of more space here like this. Then now this that was now negative square root of x times that would be, remember what is negative times positive, that is negative. Then we have square root of x all squared. Okay, because it's square root of x times square root of x, that's why I'm saying all squared. Then we're gonna divide that by we're gonna have h times that. So we're gonna have h times, okay, in fact there's no need to multiply out first, so we can say we have h into square root of x plus h plus the root of x. All right, then now what are we gonna do as h tends to 0, right? So now we're gonna say this will be equal to the limit. Now all of this all squared is just what is inside, so we have x plus h. Okay, and then this here, this whole thing is gonna cancel that because it's the same thing but the signs are different. And then here you're gonna have minus, and then square root of x all squared is just x. All right, then we have divided by our h is still approaching 0. We have h into root x plus h plus root x. All right, and now we're gonna say this cancels that, and then we are left with the lim of h all over h into root x plus h plus root x, right? So now what is going to happen, this is going to cancel that, so we're left with 1 and 1. So it means now remember h is still approaching 0. So what does it mean we have? It means we have the limit of 1 all over now this is gone, so we're just left with square root of x plus h plus square root of x, right, as h approaches 0. Now we can substitute h as 0. Okay, so we're now gonna say 1 all over the square root of x plus 0 plus square root of x, which is gonna be 1 all over square root of x plus square root of x, right, which is 1 all over 2 square root of x. Okay, so this would be the derivative of f, right? Quite a lot, isn't it? But just go through it all over again, and then you can do similar problems like maybe you can find questions like the derivative of f at x is equals to 2 square root of x, right? Then you can try it and then reach out to me, then we can explore more of this. All right, thank you so much. Stay tuned in for the differentiation rules.